Sinkholes, Causes, Prevention, and Case Studies. Welcome to Blueprint to Reality, the channel where we uncover the engineering and scientific marvels behind the world's mysteries. Today, we're discussing a natural phenomenon that is as fascinating as it is terrifying: sinkholes. These sudden ground collapses can cause devastation, but understanding them can help us mitigate their effects. Let's explore sinkholes in detail, looking at their causes, prevention methods, and lessons from significant case studies. What are sinkholes? Sinkholes are natural depressions or holes in the ground that form when the surface layer collapses into voids beneath. These voids are often the result of water erosion or human activities that destabilize the ground. While sinkholes vary in size and impact, they share one thing in common: the potential for sudden, dramatic ground failure that can swallow buildings, roads, and even people. Natural causes of sinkholes. One major cause of sinkholes is natural processes like the dissolution of soluble rocks such as limestone, gypsum, or salt. Over time, water seeps through the ground, eroding these rocks and forming underground cavities. When these cavities grow too large, the ground above can no longer support its weight, resulting in a collapse. This process, known as karst formation, is particularly common in areas with heavy rainfall or flooding, which accelerates the erosion process. Human-induced causes of sinkholes. However, human activities can also significantly contribute to sinkholes. Groundwater overextraction, mining, and poorly planned construction are common culprits. For example, leaking water pipes or unregulated drainage systems can wash away soil, creating voids that eventually lead to sinkholes. Human-induced sinkholes are often more catastrophic, as they tend to occur in urban areas with higher population densities and infrastructure. The role of geotechnical surveys. Preventing sinkholes begins with geotechnical surveys. Engineers use tools like ground-penetrating radar, GPR, and electrical resistivity imaging to detect subsurface voids and unstable zones before construction. These surveys provide a clear understanding of the ground conditions, helping to avoid future collapses. Preventive measures and mitigation. Effective water management is crucial. Avoiding overextraction and ensuring proper drainage systems can reduce the risk of erosion. In areas prone to sinkholes, soil stabilization techniques like grouting or injecting materials into underground voids can reinforce the ground. Land use planning in high-risk areas also helps minimize potential damages. Case study: Guatemala City sinkhole, 2010. Notable sinkhole case studies have provided valuable lessons. In 2010, a massive sinkhole opened in Guatemala City, 20 meters wide and 60 meters deep, swallowing an entire factory. This disaster was caused by heavy rains from Tropical Storm Agatha, combined with weak volcanic soil and poor drainage systems. It highlighted the importance of maintaining urban water infrastructure. Case study: Florida's sinkhole incidents. In Florida, a state known for its karst geology, the Winter Park sinkhole of 1981 and the Seffner sinkhole of 2013 demonstrated the devastating effects of groundwater mismanagement. These incidents emphasize the need for strict groundwater regulation and proactive geotechnical monitoring to prevent future disasters. Engineering lessons from sinkholes. Sinkholes teach engineers crucial lessons about the interplay between geology and infrastructure. They remind us of the importance of understanding local soil conditions, planning construction accordingly, and maintaining infrastructure to prevent erosion. By integrating geotechnical science into urban and rural planning, we can mitigate the risks of sinkholes and create safer communities. Thank you for joining us on this deep dive into sinkholes. If you found this exploration informative, don't forget to like, subscribe, and hit the bell icon for more fascinating content. Together, we'll turn every blueprint into reality. See you in the next video.